trigonometry started many years ago. You know, you're talking like, say, 800 BC, they were doing trigonometry. 500 AD, 1300 years later is when they began algebra. So what were they doing for that long time? A lot of trigonometry, and all of trigonometry, can really be based back to just one idea, okay? Just one idea. And that's the unit circle. The unit circle is a circle whose radius is 1 and whose center is 0, 0. That's the unit circle. Trigonometry can really start with that idea. Do you know the equation for a circle? I've shown it to you 8 times. What? Good, you're the first class to get that. Good job. So, if the center is 0, 0, and the radius is 1, what does it become? So that is the equation for the unit circle. Notice that it comes from x squared plus y squared is equal to r squared, which is just a different way of saying what? What is that? That's just the Pythagorean theorem, right? All of trigonometry is brought right back to the Pythagorean theorem. It's like the Pythagorean theorem on steroids. That's what makes it beautiful. Now, the unit circle, some people, you're going to get very involved into as we bring up trigonometry. Some people call it the circle of death. Yeah, I call it the circle of life. Okay? Circle of life. Maddie Lindley. Yeah. Yeah, it's beautiful. Yep, you're going to love it. You're going to love it. Okay? So, let's start here. It says confirm that the point square root of 3 over 2 and negative 1/2 is actually on the unit circle. Before we do that, let's see if you can actually look at the equation. Can you think of an xy coordinate that actually sits on the unit circle? Good. 0, 1. 0, negative 1. Negative 1, 0, 1, 0. Good. Those are 4 points that we know are on the unit circle. Pretty easy to come up with, right? Well, if we want to check to see if this point's on the unit circle, we're going to plug it in. I get the square root of 3 over 2. I'm going to square that. Plus negative 1 over 2 squared. I'm going to see what I get. If I square the square root of 3, I get 3 over plus 1 over 4 is 4 over 4, which is 1. So did it satisfy the unit circle? Yes, so it is a point on the unit circle. All good? Okay. If this is the unit circle, you can tell that this coordinate would then be 1, 0. This would be 0, 1. This would be negative 1, 0. This would be 0, negative 1. Example 2 says point P lies in the third quadrant and the x-coordinate is negative 2/5. Find point P. Okay? So, if I'm in the third quadrant, I'm over here. So it's a point on the unit circle. I know that it has an xy value. What's the x value? How would I find the y value? Plug it in. X squared plus y squared is 1. Negative 2 over 5 squared plus y squared is equal to 1. 4 over 25 plus y squared is equal to 25 over 25. So y squared is 21 over 25. Take square root. Y is, I'm square rooting a variable that's squared, so I have to list positive and negative root of 21 over 5. So is it the positive or the negative? Why? This is in the third quadrant. So therefore, I have negative 2/5 negative root of 21 over 5. See that? Now, it's true that negative 2/5 and positive root of 21 over 5 is also a point on the unit circle. That just happens to be up in the second quadrant, not the third. You all good? Okay, flip it over. Okay, and so here we go. Maydi, okay? Yeah, yes. Whatever. Okay. Afghanistan, right? Okay. So, if I Maydi, okay? I am 5 feet 8 inches. In Afghanistan, how would you measure your height? Well, I'm 1.75. I'm 1.75. That's ridiculous. I'm more than 1.75, aren't I? No, I'm not. Shoot. Dang it. Why? Why do you use that? Why? Why not just do feet? It's easier. Yes, thank you. You're absolutely right. And you know what? The metric system is easier. But Jessica made the point that I want to make, okay? Because right now you said the metric system is easier, right? Well, radians is easier than degrees. But you're gonna want to resist it. You're gonna want to resist it because we talk about feet, and Afghanistan we talk about meters, right? Okay. Well, we talk about measure of angles in terms of degrees. And you're used to that, right? And that's excellent application to the real world. But when you get to mathematics and calculus, we're working in radians 98% of the time. There's only one day we don't work in radians. And so here we are, and we always start over on this side of the circle, okay? You always start on the right side of the circle. This is 360 degrees, which is once around the circle. So if I ask you what is 1 degree, conceptually in your mind, you think about 1/360th of the rotation, correct? And so if I ask you to draw 1 degree, you'd be like, well, just draw a little sliver there. And I'm pretty sure that I overestimated, but we're just talking about 1/360th. Is everybody with me? Well, then what the heck is a radian? Well, right away you want this. You want, well, is a radian 1 degree? Is it 2 degrees? Is it 20 degrees? It's different. It's hard to think about it. Like, is there an exact conversion between feet and meters? There is, but you don't know off the top of your head, right? It involves some decimals, whatever. Okay, it's like, I don't know, 3.24 feet or something like that is equal to a meter. Okay, whatever. Okay, I don't know what it's about. Just give me a second. Yes. Okay. Okay, so here I am. So we want some aha moments to happen here. Be present so that the aha moments can happen, otherwise they won't. The word radian comes from radius. And because it comes from radius, that should help you remember what 1 radian is. 1 radian is the angle that's formed when I wrap a radius on the outside arc. So, watch. If I wrap something on the outside arc like that, did I wrap exactly 1 radius, more than 1 radius, or less than 1 radius? Everybody agree that this is more than 1 radius? like this would look like 2 or 3 radiuses. What I'm saying is, when is this green length the same as the blue length? That's what I'm saying. So, Kenzie, can you help me out? Okay, you tell me when you think I get to a spot where I've wrapped exactly 1 radius, when the distance of the arc is the same as the distance of the radius. You got it? You ready? All right, tell me when to go. Right there? What do you guys think? Okay, you think it's too long? Okay, I think you should be quiet. Okay. All right, Rowan, you tell me. Talk loud back there. Too short? You get the idea, right? When you got R, R, and R, that's 1 radian. Theta is what we use to measure degrees. It's the variable that we use to measure angles, okay? So that would be approximately 1 radian, okay? I'm gonna draw another radian, okay? Watch, here I go. Okay, there's another radian. Now I've got 2 of them. I'm gonna draw another one. I've got 3 of them. Yep, I'm gonna draw another one. I got 4 of them. Draw another one. I've got 5 of them. Draw another one. I've got 6 of them. Here's the aha moment. Maybe can't talk. All right. It looks like there's just a little bit more than 3 that fit halfway around the circle. It looks like there's just a little bit more than 6 that fit in an entire circle. Just a little bit more than 3. .14. There's exactly pi of these that fit halfway around the circle. There's exactly 2 pi of these that fit all the way around the circle. Now you're like, how is that? Part of you thinks it's coincidence for a second. It's like, how could it be that perfect? It's not that big of a deal, guys. Watch. What's the formula for circumference? 2 pi r. See, there's 2 pi radiuses that fit entirely around a circle. So therefore, if you're in the unit circle, what's the radius of a unit circle? 1. So therefore, 2 pi is the distance around the unit circle. See it? Yeah. There's a connection. So, awesome. We still have the connection right here, okay? We're going to convert between degrees and radians. I'm going to show you how to do it. I'm going to show the formula. I'm going to show you how to count. We got 2 ways of doing it, formulas and counting. If you want to go from degrees to radians, take theta and multiply it by pi and divide it by 180. Why? Because there's pi radians in 180 degrees. If you want to go from radians to degrees, you're going to take theta, you're going to multiply by 180, and you're going to divide it by pi. Why? Because there's 180 degrees in pi radians. All right. I'm going to teach you how to use the formula, but using the formula is simple. Right now, I'm going to teach you how to count. Teaching you how to count is more difficult. Let's go. 0 degrees, also known as 360 degrees. Boom. We all good? Start there. Tell me, what's this spot? 180. Sweet. How about here? 90. And I want to keep a good tempo because we want to get this quickly, but at the same time, I don't want to lose you. So Please try to keep up and tell me if I'm going too fast. How about this spot? 270, good. Excellent. I got 4 corners. 90 divided in half is 45. All right, let's mark off some of those 45-degree angles. Then we got that 45, then we got 90, then we got 135. Good. I got 180, then I got 225. Good. I got 270, then I got 315. Very good. Excellent. Good work. You're extremely intelligent. I'm very proud of you. Okay, take the 90, divide it by 3, and you get 30, 60, 90, 120, 150, 180. Louder duets. 210, 240, 270, 300, 330. Awesome. Great. So we know our degrees. Pat yourself on the back. Say, way to go, me. Okay. Okay. Olivia did not do well. Okay. All right. Okay. All right. Give me another chance tomorrow. All right. Now, let's do the complicated thing. Let's pair each one of these degrees with a radian. We know that 0 degrees is the same as 0 radians, and 360 degrees is the same as how many radians? 2 pi. From there, we will generate all the others with no problem. This is important. You're going to use this skill. What's 180 then? Is everybody with me? Then what would 90 be? Half a pi, or pi over 2. Now, watch me count. 0, 1 pi over 2, 2 pi over 2, 3 pi over 2. Does it make sense to you? We said we were going to do an E day, didn't we? Yeah. So, or was that was just third hour. Third hour, sorry. Third hour. We'll bring you guys in the loop. Okay. So, every day is a math holiday. All right. So, look, does it make sense to you that 3 90s and 3 pi over 2s make 3 pi over 2? Okay. All right. Half a pi over 2. Pi over 4. Sweet. I will count. 1 pi over 4. 2 pi over 4. 3 pi over 4. 4 pi over 4. 5 pi over 4. 6 pi over 4. 7 pi over 4. Sweet. I'm counting the 45s. 1 pi over 4. 2 pi over 4. 3 pi over 4. 4 pi over 4. 1/4. 2/4. 3/4. 4/4. Because it's 1 whole pi. All right. Take 180 divided by 3. You get 60. So 60 is pi over 3. Let's count it. 1 pi over 3. 2 pi over 3. 3 pi over 3 is 180. And then I got 4 pi over 3. 5 pi over 3. Watch. We're going to go every 60. 60 degrees, 1 pi over 3. If I go 60 more, that brings me to 120. And then 60 more, 60 more. We have to go by 60s. So now we'll go 180 divided by 6, and I get 30. So 30 is pi over 6. So I'm going to rotate 30 degrees each time. Watch as we count it. 1 pi over 6, 2 pi over 6. See how that's the same as pi over 3? 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6. Now, you want to get really good at this quickly for it. So, I showed you how to count. Now let's show you how to quickly use the formula. We got 4 minutes. Okay? We want to rewrite a few of these so that instead of a degree, we turn it into radians. 0 degrees is 0 radians. But if I want to turn 30 degrees into radians, you can see from the chart that it's pi over 6. Well, let's use the formula. 30 times pi over 180. That's how we convert from degrees to radians. And I then want to simplify that expression. How does 30 over 180 reduce? 1 over 6. So I got pi over 6. Let's try a more challenging one. I'm converting from degrees to radians. I'm sorry if it didn't happen to you. I encourage you to rewatch video. Okay, here's what we'll do. We'll do 360, okay? Then there's 2 pi radians in 360. What does that reduce to? You could use either or. If you're going to convert feet to miles, you would say 1 mile, and you would say 5,280 feet, right? You say how many miles, how many feet? There's 2 pi radians, there's 360 degrees. Or there's pi radians at 180 degrees. Either way, it's the same. That's our conversion. Let's try one that's a little bit more challenging. 105 times pi over 180. I want to take 105 degrees and convert it to radians. I got to simplify 105 over 180. What are both those divisible by? 5. 105 divided by 5? 21. 180 divided by 5? 36. Are 21 and 36 both divisible by the same numbers? What? So I get 7 pi over 12. So 7 pi over 12 is the radian measurement that corresponds to 105 degrees. I'm going to hand out an assignment that we're going to do. Okay, real quick, watch. So the first one says 290 degrees, negative, and you want to convert it from degrees to radians. Our conversion is to multiply by pi and divide by 180. What are 290 and 180 both divisible by? 10. So negative 29 pi over 18. Done. Nope. You only have to do the odds on the worksheet. Please look at number 21. 21 says take pi over 18 radians and convert to degrees. If I'm going the other way, I multiply by 180 over pi. What happens to the pi's? What's 180 over 18? 10 degrees. Do the odds, practice converting back and forth. That's it. We pick up with the same topic tomorrow. Both sides, odds, odds,